Hello student, today we will start chapter 4 Motion in a plane. First we will discuss scalars and vectors. The physical quantities which have only magnitude and no direction are called scalar quantity or scalars. A scalar quantity can be specified by a single number along with the proper unit. For example, mass, time, electric current, etc. The physical quantities which have both magnitude and direction and obey the laws of vector addition are called vector quantities or vectors. A vector quantity is specified by a number with a unit and its direction. For example, displacement, velocity, force, etc. A vector quantity is usually represented by single letter of alphabet either in boldface or with an arrow over it. The magnitude of a vector is a positive scalar or is written as either mod a vector or a, that is modulus of vector a is equal to a scalar. A vector can be represented by a straight line with arrow head on it, that is an arrowed line. Here the length of line drawn on suitable scale represent the magnitude of vector and arrowhead represents the direction of a vector. The starting point of arrowed line is called tail or origin of vector and the end of the arrowed line is called tip or head of the vector. Suppose a body has a velocity of 20 km per hour due east. If 1 centimeter is chosen to represent a velocity of 10 km per hour, a line OA 2 centimeter in length and drawn towards east with arrowhead at A will completely represent the velocity of body. Next, types of vector. First, equal vector. Two vectors A vector and B vector are said to be equal when they have the same magnitude and the same direction and represent same physical quantity. If a vector is displaced parallel to itself, it remains equal to itself. Equal vector A vector and B vector both are equal vector because magnitude means length of A vector and B vector same and direction is also same. So both A and B are called equal vectors. Next, Second, negative of a vector. A negative vector of a given vector is a vector of same magnitude but acting in a direction opposite to that of given vector. So a vector, so negative of a vector in opposite direction, so represent with minus a vector. Next, third, unequal vector. First, when two vectors are equal in magnitude but directions are different. Magnitude equal means length equal but direction different. Second, when two vectors have equal direction but magnitudes are different are also called unequal vectors. Means direction same but magnitude different. Third, when two vectors have unequal magnitude and direction, means both different magnitude and direction, both different. Next, fourth, unit vector. Unit vector. A unit vector of the given vector is a vector of unit magnitude. Means magnitude of unit vector is always 1 and has the same direction as that of the given vector, or a unit vector in the direction of a given vector is found by dividing the given vectors by its modulus. Thus, a unit vector in the direction of vector A vector is given by A cap. Unit vector represent with cap. A cap is equal to A vector upon modulus of A vector, or we can write A cap is equal to A vector upon A, or A vector is equal to A into A cap. It is unitless and dimensionless vector and represents direction only. Magnitude of a unit vector is unity. I cap, j cap and k cap are called orthogonal or rectangular unit vector. I cap represent in x direction and j cap in y direction and k cap in z direction. So I cap is equal to x vector upon x, or x vector is equal to x into I cap, and j cap is equal to y vector upon y, or y vector is equal to y into j cap, and k cap is equal to z vector upon z, or z vector is equal to z into k cap. Example, find the unit vector of A vector is equal to 4 I cap minus 3 j cap plus k cap. So solution of this question, let A vector is equal to ax I cap plus ay j cap plus az k cap. Therefore ax is equal to 4. Compare both equation. Here ax is 4, ay is -3 and az is 1. Hence a vector mod is equal to a is equal to ax square plus ay square plus az square. Put the value of ax, ay and az. So 4 square plus -3 square plus 1 square or under root 26. A cap is equal to a vector upon a is equal to 4 I cap minus 3 j cap plus k cap upon under root 26. Next, angle between vectors. When two vectors are in the same direction, then the angle between these two vectors is 0 degree. And similarly, when two vectors are directed along the opposite direction, then the angle between them is 180 degree. Opposite direction, so angle between 180 degree. When two vectors are placed with their tails at the same point, then the angle between them, which is less than 180 degree, is called angle between two vectors. Suppose a vector, here it is b vector, both tail at same point O, so angle between theta. Next, addition of vectors. The addition of vectors is different from scalars due to magnitude and direction. The addition of physical quantities are based on the following points. First point, any vector quantity in parallel and equal magnitude can be displaced at any place. Second, two vectors can be added if both of them are same units or nature. Third, when two vectors are added, we get a single vector called resultant vectors. The magnitude and direction of resultant vector r vector can be known with the help of some following rules. A. Triangle law of addition of vectors. B. Parallelogram law of addition of vectors. C. Polygon law of addition of vectors. So first, A. Triangle law. According to the triangle law or triangle method of vector addition, if two vectors are represented in magnitude and direction by the two sides of a triangle taken in an order with the tail of one vector lying on the head of the other. The resultant of the two vectors in magnitude and direction is represented by third sides of the triangle that is taken in the reverse or opposite order. Suppose we have to add two vectors p vector and q vector. So here it is p vector represent with AB sides. Next, second q vector represent with BC sides. Now displace q vector parallel to itself in such a way that the tails of q vector touches the tip of p vector. So displace the q vector BC here represent with q vector. Complete the triangle according to triangle law to get a new resultant vector. P plus Q is equal to R vector running straight from the tails of P vector to the tip of Q vector. So according to triangle law, it is represent resultant of P vector and Q vector represent with R vector. So R vector is equal to P plus Q vector. To determine the magnitude and direction of resultant vector of two vectors. A. Magnitude of resultant vector R vector. Suppose two vectors P vector and Q vector have resultant R vector. P vector and Q vector have R vector. Let theta be the angle between the vectors P vector and Q vector, here angle theta, and alpha be the angle between resultant vector R vector and P vector, here it is alpha. Let the vectors P vector and Q vector be represented by the adjacent sides OA and AB of the triangle OAB respectively. According to the triangle method of the vector addition, the resultant of the two vectors, that is R vector, is represented by the sides OB, which is taken in the opposite order as shown in the figure. Let us draw a perpendicular BN on the sides OA extended to point N. In triangle ABN, cos theta is equal to AN upon AB, or cos theta is equal to AN upon Q, since AB is equal to Q, or AN is equal to Q cos theta, and sin theta is equal to BN upon AB, or sin theta is equal to Bn upon Q, or Bn is equal to Q sin theta. It is equation first. It is equation second. Further we can write ON is equal to OA plus AN from figure. Here it is ON is equal to OA plus AN. So OA P plus AN from equation first, Q cos theta. Clear? Next, using Pythagoras theorem by right angle triangle OONB, we get OB square is equal to ON square plus BN square from triangle ONB, or OB square is equal to ON from equation third, OA plus AN whole square plus BN square, or OB square is equal to OA square plus AN square plus 2OA into AN plus BN square, or OB from figure R square, and OA P square plus from equation first AN Q square cos square theta plus 2 OA P and AN from equation first Q cos theta plus BN square from equation second Q square sin square theta, or R square equal to P square plus, here Q square common, so Q square sin square theta plus cos square theta plus 2PQ cos theta. Since sin square theta plus cos square theta equal to 1, so we can write R square equal to P square plus Q square plus 2PQ cos theta. It is equation 4. It is the resultant of P vector and Q vector, or we can write R equal to under root P square plus Q square plus 2PQ cos theta. It is equation 5. Next, B, direction of resultant from right angle triangle ONB. Tan alpha is equal to NB upon ON from figure, or tan alpha is equal to NB upon ON. We can write OA plus AN, or tan alpha is equal to Q sin theta upon NB from equation 2. OA P plus AN from equation first. an put q cos theta, or we can write alpha equal to tan inverse q sin theta upon p plus q cos theta. That is equation 6. Next, special cases. First special case is when P and Q are in same direction, that is theta equal to 0 degree. So from equation 4, from equation 4, R equal to P square plus Q square 2PQ cos 0 degree. Here theta is 0 degree. Since cos 0 equal to 1, or R equal to P square plus Q square plus 2PQ, or R equal to P plus Q whole square, or we can write R equal to P plus Q from equation 6. From equation 6, alpha equal to tan inverse Q sin 0 upon P plus Q cos 0. Since sin 0 0 and cos 0 1, so we can write alpha equal to tan inverse 0 equal to 0, since tan inverse 0 equal to 0. Next, second case, when P and Q vector are perpendicular to each other, that is theta equal to 90 degree. From equation 5, R equal to P square plus Q square plus 2PQ cos 90 degree. Since cos 90 degree equal to 0 degree, 0, or R equal to P square plus Q square. From equation 6, we can write alpha equal to tan inverse Q sin 90 upon P plus Q cos 90. Since sin 90 equal to 1 and cos 90 equal to 0, so alpha equal to tan inverse Q upon P. Next, third condition, when P and Q vector are in opposite direction, that is theta equal to 180 degree. From equation 5, R equal to P square plus Q square plus 2PQ cos 180 degree. Since cos 180 degree equal to -1 and sin 180 degree equal to 0, so we can write R equal to P square plus Q square minus 2PQ, or R equal to P minus Q, or q minus p. From equation 6, alpha equal to tan inverse q sine 180 degree upon p plus q cos 180 degree, or alpha equal to tan inverse 0 equal to 0, or 180 degree, when p is greater than q, and 180 degree when p is less than q. That's all for